Welcome to JSA TV, where we're covering the latest news, trends, and innovations from thought leaders like these two wicked smart gentlemen to my right from within the digital infrastructure industry. I'm Dean Perrine, and we are coming at you live. That's right, we are live in beautiful Honolulu, Hawaii for PTC 2026. And the guys to my right are Matt Brisbois, or Brisbois. It could be either, as you said.
It could be either one.
We're going to go with Brisbois because it sounds very, very cool.
Right, yeah,
and I practiced saying it. So Matt is the business development manager for Modelon. And we also have Lixiang Li. Li is the head of customer success at Modelon. Gentlemen, welcome to JSA TV.
Thanks, Dean. Appreciate it.
Yeah, thank you. And how is the show going for you so far?
Fantastic. We've had some really fun, interesting discussions. I think we've learned a few things.
Yep.
Met some new people in the industry. Yeah,
very cool. Is this the first time you've been here, or?
It's our first time to PTC.
So, gentlemen, you have come to the right PTC because, as I understand it, and I've been to the show a number of times, but it is growing exponentially. So you're coming at the perfect time. And JSA viewers, you are watching at the perfect time because we are about to get a little bit educated. Lee, this first question is for you, sir. How does physics-based simulation change the way data center cooling systems are designed? I told you, we're going to get educated about right now.
Good question. So traditionally, we think of design to commissioning of data center as a very linear and serial process. Mm-hmm. For example, engineer will look at, say, the steady state performance and capacity of the cooling system, and then operation and control of that it's an afterthought.
Uh-huh.
That leads to surprises when people are commissioning the data center.
Yeah.
Not a pleasant
Nobody
surprise.
likes surprises.
And there's gaps between the design and reality all the time.
Sure.
And so with physics-based simulation, people are able to look at the whole system, including all the components, cooling equipment, integrate it all together way before the equipment arrives, so that they can make informed decisions about sizing, vendor selection, and then co-optimize the system design and the control of it, really squeezing out performance out of the same equipment.
Okay. I'm going to try to boil it down for my brain. This sounds like a risk mitigation play too. If you've got that kind of investment in something, you want to make sure that the thing that you're doing is going to be successful, and that's what this does.
Yes, absolutely. So we talk about moving towards the design phase more and more, mitigating the risk, burning it down way before the bricks and mortar are in place.
So one of my favorite terms, and I'm still trying to come to grips with it, is a digital twin.
Yep.
So, Matt, tell us a little bit about Modelon and the digital twin strategy that you have.
Yep. So as Lixiang pointed out, like once you have models generated and you have a bricks and mortar data center, data hall up and running, the Modelon models can inform the digital twin, so integrated and informing a holistic view of the data hall. And with that view, you can get sort of a bird's eye view right down to the component level within the hall, so down to a chiller or heat exchanger. And with that detail, you can look for things like degradation in the component itself, performance lapses, thermal events, things of this nature. So you can really look at things that help you predict maintenance issues, get ahead of additional risk, failures, things of this nature.
Okay, I think I'm getting it, guys. So this is good, and I'll just say this now: nobody leaves the JSA TV chairs without talking about AI, as you might imagine. So Lee, back to you. We're going to talk about AI workloads being highly dynamic, and why is transient analysis. This is the first time I've ever asked this question. I can promise you that. Why is transient analysis, understanding what happens during spikes and disturbances, so important in a liquid cooling environment?
Yeah, so as you said, AI workload is highly dynamic.
Yeah.
So during training or inferences, the workload just come in, and you got these huge GPUs that are dumping a lot of heat really fast.
Yeah.
So what you want to avoid is heating up the chip and then causing a failure in the system. And to do that, you would need to orchestrate all the equipment in a really responsive way. And of course, you don't want to oversize your system. That's huge loss in investment and lots of operating costs as well. So being able to analyze performance in a transient way, then designers and operators can really hone in on the optimal performance and look for opportunity to innovate and operating and designing the data center.
Lee, you're really good at this.
No,
you are very, very good at this. Thank you so much for that. I mean, as you guys were talking to me a little bit more about Modelon, my immediate thought was like probably 75% of the people in this building right now could benefit from, at the very least, a discussion with you all about how you might be able to help them.
We like to think so.
Yeah, well, welcome to PTC, you guys. Thank you for being here.
Thanks, Dean.
Thank you for
Appreciate
having
it.
us.
You bet, you bet. And thank you, viewers, for watching JSA TV. We will see you very soon.